All right, so the last part of 3.2, we're talking about regression to the mean, regression to the mean. Regression to the mean. You guys heard this before? Have you guys heard this? Regression to the mean? Regression to the mean usually means that you're going to fall back to the mean. You're going to come back to the mean. So if you are a 80% free throw shooter and you make like 10 in a row, okay, it's kind of like where they say, well, you're due for a miss, right? You're going to come back to earth. You're going to come back to what your average is, right? That's kind of what the regression to the mean is, right? So let's go to page 194, and then there's a green box there that says, how to calculate the least squares regression line using the summary statistics, okay? And it gives you a couple of equations there, okay? The bottom one is one you already know, right? I mean, there isn't anything much there, right? It says that y bar minus b1 x bar is equal to b naught, right? And this is more, if we just move it over, we get what y bar is equal to b1 x bar plus b naught, okay? This is just a slope-intercept equation, right? So there's nothing interesting here. The one that's interesting is the one on top, right? We have what? B1, which is the slope, is equal to r standard deviation of x over standard deviation of y, okay? So it has a standard deviation in the y direction and standard deviation in the x direction, okay? So what that basically means is this. If you had a regression line that looks like this, okay? The regression line is, if I go standard deviation just one s sub x here, I'm supposed to go all the way up to s sub y, okay? But it won't fully go there. It'll go only part way here, okay? It'll go from here, not all the way here, but it'll only go up to here. So in other words, it's gonna go r s sub y, okay? R as being this is less than 1, okay? So so instead of going, so it's going to go s sub y over r s sub x. So s of x, instead of going all the way s of x, it's going to go slightly less than that. In other words, instead of going all the way up here, all the way up to here, it's going to regress down back to the mean. That's what it means, okay? And that is on page 196. If you look at page 196, it shows you that, right? You have the s of x and you have the s of y. Instead of going full s of y, it goes something less to that. Okay, that means it's going to regress. It's going to fall back down lower to the mean. Okay. Regression to the mean. Just understand that what this is. Okay, understand what it is. Understand that you can use this equation here to calculate the slope. Okay, you can do that. You can use that. Okay. So if you look at page 197, it says the correlation and regression wisdom. Okay, so these are some of the interesting things about correlation and the regression to the mean. Okay, first one says correlation and regression lines describe only linear relationships. Okay, this makes sense, right? It only works when you're talking about linear relationships. Okay, you can't use this on something that does not look like a line. Okay. Correlation and least square regression lines are not resistance. Uh-oh, that resistance thing again. So it's not resistance, meaning what? It is susceptible to what?
Outliers.
Outliers. It's susceptible to outliers, right? So you have to always take a look and make sure that there aren't any outliers. Okay, if you flip the page, there's a long drawn out discussion on page 199 about, you got those 3 lines there, you know, child 19 and without child 19, without child 18. It shows you how greatly 1 or 2 outliers can distort or move the least square regression line, okay? Therefore, again, the least square regression lines are not resistance, which means that you have to get rid of them. You have to take them out. You just don't use that data point, okay? So that's how you would treat outliers in this when you're doing a regression line, okay? Flip the page, go to page 201. Page 201, it says, again, association does not imply causation, okay? We've heard this, I think this is like the 3rd or 4th time already. Okay, I told you, this comes up quite often, okay? There are very, very specific conditions that have to be met for you to be able to say that there is causation. And actually, we're gonna start learning that in chapter 4, when you design experiments. Okay, how can you design an experiment so that you can say there actually is causation? Okay, so we'll learn an example in chapter 4. But before that, again, right now, correlation, again, does not mean causation. Okay, and there are some examples here that I skipped. Okay, and you know, they're pretty simple. That's why I skipped them. You can read them, all right, if you want. And that's it. Since you're already taking notes, you should all know this stuff anyway. All right, are there